Good morning, everyone. Thank you for the time. Today I'm going to show a very simple way to see where our AI looked when it flags an image. It's called Grad-CAM. This helps us build trust with clinicians, move with speed when something looks off, and improve governance because we can save the explanation with the case. Let's start with a quick visual what this looks like on a chest X-ray. Here's a chest X-ray over AI flagged. The color layer shows where the AI looked to make that call. Bright colors mean it paid more attention there. Cooler colors mean it mattered less. Think of this as a visual receipt for the decision, no equations, just a picture. It helps radiologists judge the flag, lets leaders and auditors see the why, and gives us a record we can keep for quality and compliance. Let me define Grad-CAM in one plain sentence. Grad-CAM is a colored layer or heat map on the X-rays that shows where the AI looked when it made a finding. Grad-CAM simply puts a color layer on the image. Bright matter more, cool matter less. If the AI says possible pneumonia, the bright area should sit on the consolidation, not on labels or the background. Why does this matter to us as a CXR program? Seeing the bright area on the true finding builds confidence. When a result looks odd, we can tell right away if the model looked in the right place, which speeds follow up. And we store the explanation with the case so QA and auditors have a clear record. Net effect: better trust, faster workflows, stronger compliance. Here's where this helps first. These are the first wins. For pneumonia, we expect the bright area over the opacity. For pneumothorax, the focus should sit on the pleural H, not labels. For lines and tubes, the attention should trace the device and tip. For cardiopulmonary patterns, attention should stay over the heart and lungs. Here's how Grad-CAM works, no math. Think of a flashlight on the image. The bright spots are where the AI gathers most of its evidence. Grad-CAM just turns that into a simple color layer we can read. Let me show that flow on one case. Left, the original study. Middle, the raw color layer. It can look blocky but shows what influenced the model. Right, the overlay, which is easier to read. In a good case, the bright region lines up with the clinical target, such as a lower lobe opacity and the pleural line. If it lights up labels or corners, that's a signal to investigate. What outcomes do we expect? We'll treat this like any operational improvement. We expect faster review, fewer disagreements on edge cases, quicker audits because explanation is saved, and a small confidence pulse with readers. We'll also use this responsibly. This shows influence, not certainty. It supports clinical judgment, it doesn't replace it, and Grad-CAM is for image. Other data types use different explainers. Here's how we make this audit ready. We'll save the explanation with context, add a one-click blur test to confirm it matters, monitor for bias across scanners and populations, and follow our privacy rules. Let's prove value with a short pilot. This is a low-risk sprint. One workflow, one button, measurable outcomes. In week 5, we validate the gather feedback. In week 6, we present results and decide on scale up. Here's what we need to start. With your approval, we'll start on the selected CXR workflow. We'll name a clinical champion and data science lead and ask for about 1-2 hours per week from reviewers to try the feature and give feedback. Then we'll return with numbers and recommendation. Thank you for your time. Happy to take any questions.